Welcome back. Hope you guys were able to fill out this table. Well, in order to fill it out, you basically just need to know the coordinates of the terminal point related to each of these real numbers. Note here that these are some special real numbers that we are looking at. We are not looking at like each and every real number or a real number in general, but these special real numbers. And where did we get these special? How do we know the terminal points for these? So recall in section 1 I showed you that there are some real numbers that lie on the unit circle for which we can use some trigonometric some geometric formulas or geometric information from geometry that we learn in high school probably, that we can use to figure out the coordinates of the terminal point, or we could use algebra to find the coordinates of the terminal point as was shown in section 5.1. So once we know these, then we can look for some other real numbers which could be reflection of the ones that we know, and we can find the terminal points for those new points. So first let us see whatever is left in this table. So I see the tangent I didn't fill, and I just wanted to do it in front of you, because remember tangent of t was defined to be y over x. So our y is this value, sine value, so sine of t is y, so we will have 1/2 divided by square root of 3 over 2. It will be 1/2 divided by square root of 3 over 2. So if you do it on side, 1/2 multiplied by 2 over square root of 3. So it gives me 1 over square root of 3. So we started with 1 over 2 divided by square root of 3 over 2, which we can write as 1 over 2 times, flip the second fraction, so 2 over square root of 3, 2 and 2 cancel here, so we are left with 1 over square root of 3. We rationalize, multiply top and bottom by square root of 3. So in the bottom we get 3 and the top gives a square root of 3. So that the tangent of pi over 6 is square root of 3 over 3. Now the pi over 4, the x and y had the same value, so the tangent of pi over 4 is 1. Tangent of pi over 3 will be basically the reciprocal of tangent of pi over 6, but you can also see it here. So y over x, so y is square root of 3 over 2, and we are going to divide it by 1/2. So we get square root of 3 over 2 times 2 over 1. 2 and 2 get cancelled and we get square root of 3. So this is square root of 3. We do not need to rationalize this because the square root is in the numerator already. What about tangent of pi over 2? So it will be 1 over 0, which means it is undefined. The tangent of pi will be 0 over -1, which is 0. Tangent of 2 pi will also be 0 over 1, so it's 0. What about the other trig functions? What about the cosecant of t? Well, cosecant of t was just y. Cosecant of t is 1 over y. So at 0, the y coordinate is 0. So we have 1 over 0, which means it's undefined. secant of t x over 1 over x. X in this case was 1, so secant of t is 1. Cotangent of t was x over y, so now we will have 1 over 0, so this is undefined. Pi over 6. Pi over 6, if you recall, the terminal point was square root of 3 over 2 comma 1 half, and the secant of t was 1 over y. 1 over 1 half, which will become 2. So we have 2. Secant of pi over 6 was 1 over x. So x was square root of 3 over 2. So now we will have 2 over square root of 3, and if we rationalize, become 2 square root of 3 over 3. Cotangent will be x over y, so we will get just square root of 3. Pi over 4, the secant will be 1 over y. Y is square root of 2 over 2. Now in this case, if we recall that the square root of 2 over 2 is the same thing as 1 over square root of 2, it will be easier, because now if it is 1, y is 1 over square root of 2, 1 over y will be just square root of 2, and this will also be square root of 2, and the cotangent of t will be 1, because x over y and x and y are same, so pi over 3. So secant of pi over 3 will be x over y. So the x is 1 half. So we have 1 half divided by square root of 3 over 2. If you simplify it, it becomes 1 over square root of 3, which is the same thing as we have here. So this is 1 over square root of 3, or 2 square root of 3 over 3. So you can remember it in any form. You can remember it in this form, or you can remember it in this form. Okay, the next thing is pi over 2. So pi over 2, so the cosecant of pi over 2 will be 1 over y. So the y coordinate is 1, so we get 1. Secant of pi over 2. Now, secant of pi over 2 will be 1 over 0, so it is undefined. Cotangent of pi over 2. Well, the cotangent will be x over y. Now, x is 0 and y is 1. So we get 0 over 1, which means 0. Okay, we are left with this. So secant of t, secant of pi over 4 will be same thing as pi over 3. We are looking at pi over 3. So pi over 3 has the coordinates 1 half x over y, so 1 over 2 divided by square root of 3 over 2. So 1 over 2 divided by square root of 3 over 2. So this will be flipped, so we get 1 over 2 into two over square root of 3. So x over y, right? So this gives you 1 over square root of 3. The secant of t, secant will be just 2 because secant is 1 over x and x is 1/2. 1 over 1/2 will be 2. Now for pi, cosecant of t will be 1 over y. The y coordinate is 0. So we get 1 over 0, which is 0, which is undefined, not 0. Three pi over 2. Now the x coordinate is 0 and the y coordinate is -1. So we get cosecant is 1 over y. So we are getting 1 over -1. So -1. And secant is 1 over x. 1 over 0. Undefined. And what about the cotangent of 3 pi over 2? Well, cotangent is x over y, so we are getting 0 over -1, which is 0. What about these two left for pi? So that was secant of pi will be 1 over x. X is -1, so we get 1 over -1, which is -1. What about cotangent of pi? It will be x over y. Y is 0, x is -1, so -1 over 0, so this is undefined. 2 pi. It will have the same things as we have for 0. So this will be undefined because for 2 pi the x coordinate is 1, y coordinate is 0. The secant of t is 1 over y, so 1 over 0, so undefined. And then secant will be 0 over 1, which is 0. Sorry, it will be 1 over 1. And the cotangent will be x over 0, which means 1 x over y, which means 1 over 0, which means undefined. So now, once you can fill out this table, the first table, first one, this one, then you can now be able to find the trig functions or sine, cosine, and tangent of a real number for any real number which is a multiple of these real numbers that are given up here. We will talk about that in the next video.